All right. So we're going to clone it. And then what's next? So we're going to, so let me just be more clear about where we're going in the end, right? We're going to do the same thing we've done in the last couple of classes, where we did variables the first class, did if else the second class. We're going to do loops this class, all JavaScript still. We'll do this, and we might get into functions today. If not, we'll do that Monday, and then we'll repeat in Rails. So what I'm trying to get to is a project where I can write some JavaScript, where I can do some console logging, where we can learn stuff. Cool? Just so everybody's. All right, so what's the next step?
You could, I guess, CD inside if you want.
Yeah, so I want to CD into there, and then everything should be up to date, presumably, right?
Get status.
Get status, just make sure. All right, so we're on branch master. So what's the next step?
Check out your branch.
Get branch. Oops. All right, then we can get to work, right? So let's open up our classes. And we should have our loops. But there's nothing in it. So what I need to do?
Right there.
What do I want to call it? Okay. What's the other file I need? I'm just going to copy this one. I'm just going to copy this up next to just so we have our stuff set up. We'll look at it. We'll look at it, but at this point, there's very little there. You guys should be able to just copy and paste and get started with that. All right, so then we come in here. It's our game from last time. All right, so we're going to talk about loops. There's a couple of different ways to do loops. We're going to talk about them all broadly, and then we're going to talk really about the one that you use all the time. So the first type of loop, probably the first loop that you would learn about if you were a CS major, is looping until you hit the end of a list. So like for I equals 0, I is less than some number, I plus plus. Okay. So you're looping from 0 to 10. We did that yesterday. We had 10 steps. We stopped at each one of them and did the iteration. The second type of loop, which you generally don't talk about until a little bit later in your CS program, if that's what you're doing, is what? What's another way of looping over things? So you can do like for loops where you have a start.
Control.
What's that?
Actually, you can do a count control.
Mhm.
You could do a conditional loop, so it's like a while loop.
So a while loop, which is really close to. So a while loop is a. I don't know if you could make this connection necessarily, but what if I write a function? If instead of writing a loop, I call it function, and that function calls itself over and over again until a condition's hit. Recursion. So recursion, while loops work based on recursion. That's all they're really doing, right? It's just a function that's calling itself until a condition is hit and then it exits. Recursion is a somewhat difficult thing for us to wrap our minds around because it's weird for something to get called again and again. Most people think linearly, which is to say, I expect to do this, and then I make a decision, and then I do the next thing, and then make a decision, and I do the next thing, and make a decision, and I do the next thing, et cetera, for a very long time. This is where computers start to get confusing and where people sometimes drop out of trying to learn logic, is that every once in a while, what happens is you, in the middle of a program, end up back at the front of the program and execute back through again. And sometimes you stop in the middle of that and exit out. And so like this concept of not just, so like for example, when we read, right? When we read a book, we go one page at a time all the way through. Even if some of the concepts come back, we don't, when the concept comes back, we don't go back to where it started at. We just continue moving forward. Same thing with movies. You don't watch a movie and then all of a sudden loop back. Like even in flashbacks, it's not like you actually then go back to that point in the movie or in time and then move forward from there. And so it's a little difficult because we just don't experience this a lot in our lives, this concept of jumping back to the beginning. And that's what loops are. It's easiest probably to see that in recursion because it's literally a function that's calling itself and it only stops calling itself when some condition is met. Okay. All right. So those are the two. One is very simple. It's start at some number, end at some number. The second one is very difficult. It's keep calling yourself until some condition is met. The third one is somewhere in the middle. It's also the far more common way that we actually loop over things practically, and that's that you start with an array, a list of things, and you loop over that list doing something to them. Okay. And you guys can imagine why this would be more practical. Like you do a RESTful request to get movies from Rotten Tomato, you want to loop over them to display them on the page. Or you get a list of student records and you want to take their first name and last name and concatenate them together so you can make a PDF that says like, congratulations, Sam Birk, you've been accepted to such and such institution. Okay. So far more likely that you're going to have a list of things you want to do something to than that you're going to have an arbitrary start number and an arbitrary end number that you're trying to do stuff with. Happens sometimes, but it's rare. Okay. When you have a loop, because you have the start and the end, and it's defined by the length of the list that you're working with, you also don't need recursion. Now, in many cases, behind the scenes, what's actually happening is recursion, but you can think about it in a much more linear way. So it's much more consistent with how we're used to thinking, which is I'm going to start with the list item 1, and then I'm going to go 2, and then 3, and then 4, and then 5. And even though I'm starting over inside of my loop, I'm reading the items forward, okay, which is helpful. So most of the time, I'd say like 85-90% of the time when you're iterating over something, when you're looping over something, you're going to be using a list to do it with. Okay. So we're going to spend most of our time on that list. I'm going to very quickly show you guys what it looks like to write a for loop and then recursion, and then we're going to spend most of the time in list loops. Okay. All right, so we did the simple version for that I equals 0, I is less than 10, I plus, so that log I. So what's going to happen if I run this code? Yep, one at a time, right? Because it's going to go, okay, 4, we're going to start at I, so the first iteration, and this is just to help. I mean, you guys, I think, get this probably, but just to explicitly state it, when we're looping over something, when we're doing a for loop, it's doing it based on the conditions that are here as our parameters, but it's going to execute what's between the two curly braces one at a time for each iteration of the loop. Okay, so when I equals 0, we're going to stop here and we're going to print I. When I equals 1, we're going to stop here and we're going to print 1. When it's 2, we're going to stop here and print 2. When it's 3, we're going to stop here and print 3. So you need to think about, we're going to do this over and over and over again, one at a time until we reach the end of our loop. Okay. So we can see that happen if I open this in a browser. 0, 1, 2, 3, 4, 5. Just to prove that it stops. And again, I know this is somewhat redundant, but I think it helps to just like force these fundamentals of what's actually happening here. We're going to put a debugger in and we're going to stop it. So here we are. We're at the beginning of our loop. We haven't printed anything yet. If I look at what I is at the moment, it's 0. If I click next, it's going to finish this iteration of the loop, and then it's going to start back up at the top again. So then so now we've printed 0, now we're back at the top. I is now going to be 1. We're going to go and actually print it. We're going to be back at the top of the list. It's going to be 2, 3, 4, 5, 6, 7, 8, 9. We've reached the end of our condition, so we're done. Make sense? Very good. All right. Step number 2, recursion. I'm gonna write a function. I'm gonna write it using the AS6 syntax just because you guys should start to get familiar with that. But I'm gonna say something like curse if I is 9, return otherwise console log I. All right. So who wants to try to walk through this?
Okay, so passing in 0.
So let's start. I want to get a little bit of familiarity with like the way I want you guys to do this. We start at line 1 all the time, and we're going to say what's happening at line 1. So what's happening at line 1?
You declared a function named recurse that takes in an integer.
Yep. More specifically, I'm assigning a variable named recurse to an anonymous function. It's called to a function that takes in I. Now, this is just, it's an interesting syntax. There's some reasons for this. We'll go over for why JavaScript does it. In the end, yeah, I'm declaring a function that takes in an integer I. Okay. But yeah, that's all I care about. There's a function, I'm creating a function that takes in a single parameter that's I. Yep. Okay. So now what I want you to do is think about this as a computer actually executing this script, right? So there's been a function that's created, but what executes next? Where does the computer go from here? So line 1, there's a function, now what?
Alright, so are we looking at line 2 now?
Does it? Where would the computer go? So
I mean,
it's
a computer would like see the declaration,
Yep.
and that'd be fine, but
Yep.
it wouldn't do anything until it sees its call.
There you go. So that's how we want to read this, okay? So I don't want you to tell me what's on line 1, what's on line 2, what's on line 3. I want you to tell me, as a computer, if I started executing this code, what would I do? And the computer would say, there's a function named recurse defined on line 1. I know what its definition is, but I'm not going to go inside of the definition because I don't need to execute that because it hasn't been called. So I'm going to skip to line 8 because that's the next thing that actually happens. And on line 8, what happens? Yeah, I called recurse with what?
Parameter of 0.
Parameter of 0. So that then now what happens next?
How it goes and looks on the symbol looks for the definition.
Now it looks for the definition, and then what line does it go to next?
It's gonna go back to 1.
Does it go back to 1?
Alright, so like a computer is like for its definition is keeping a pointer of like the location.
Yep. So it goes back to 1 to get the definition, but then what's the next line that it executes?
2.
2. Okay.
And then
So then at that point, so when we're back there on line 2, what is I at that point? Wait, what is it?
Well, it starts at 0.
It's 0 because we passed in 0 as the parameter. So what we're doing down here is saying declare I as 0 when you start. Okay. So then it's going to say so I is 0. So does 0 equal 9? No. So what's going to happen next?
Line 3.
So then we go to line 3 because we're not going to return. We're not leaving the function. So we go to line 3. What does line 3 do? It prints what? 0. Yep. So it prints 0 to the console, and then line 4 does what?
Or go back to.
Not quite yet. So what's line 4 do? This is syntax we talked about briefly yesterday. It's the same as. So where's line 4?
Oh, it adds 1 to 0.
Yeah, so it adds 1 to 0, which is going to be what? So then what's I on line 5? Yep. So then what happens on line 5?
Function calls itself with, now the parameter is 1.
Yep. So we're going to call the recurse function again with the parameter 1 now because we just bumped I to 1, right? So what is that going to do? So if we're calling recurse, where do we go from here as a computer?
Back to line 2.
Back to line 2. So what's I at this point? 1. Does 1 equal 9? So then we go where? Line 3. What does line 3 do?
It prints 1.
Yep. Prints 1. We go to line 4. What does line 4 do?
That's 1, 2. So it becomes 2.
So I becomes 2. So then line 5 does what?
Prints 2.
Line 5 doesn't, well, I mean, it will, but not yet.
Technically.
So, yeah, this is where, yeah, we're slowing down a little bit. So, like, what does line 5 do? How does the computer interpret that? I basically want to know, where do we go next? So, line 5.
Line 5 is going to take you back to line 2 because it's being called. It's going to.
Yeah, so line 5 is calling the function recurse with I being 2 now. So we're going to go back to line 2. So on line 2, what is I at this point?
2.
2. Does 2 equal 9? So we go to line 3. What does line 3 do?
Prints 2.
Prints 2. So we go to line 4. What does line 4 do?
So it becomes 3.
So it becomes 3. So what does line 5 do?
It goes back to 2.
It goes back to 2 because we're calling the recurse function again. Right? So it's the same thing that happened on line 8. It would be the same thing that would happen if we did it again on line 9. It's calling the function with the parameter. In our case, this parameter just keeps increasing because we're increasing it right before. So, okay. So now recurse is being called with 3. So we go back to line 2. 3 does not equal 9. Print 3. Set I equaled 4. Call recurse with 4. That brings us back to 2. 4 does not equal 9. 4. 5. We call recurse with 5. 5 does not equal 9. 5. 6. We call recurse with 6. 6 does not equal 9. Print 6. 7. We call recurse with 7. 7 does not equal 9. We print 7. 8. Recurse 8. 8 does not equal 9. Print 8. 9. Recurse with 9 as the parameter. Does 9 equal 9?
Yes.
So what happens?
Exits.
It exits. We're done. So, what was the difference between what we just did here and the for loop that we wrote a moment ago?
Syntactically or in general?
In practicality, in terms of what it does.
Nothing.
Nothing. They're exactly the same. Does that make sense? So let's just see it. I broke something.
10. No. Because you remember we were going up to 10 in the last loop,
Mm-hmm.
and then now we have it at 9. We're exiting, so we never get to print.
Oh, I didn't go far enough. Yeah.
There we go.
Cool. Everybody sort of get what's going on here. You don't have to do recursion very often in programming. It's something you will absolutely run into at some point, but it's like a once a year particular problem set problem, not a most of the time thing. But it's good to know that's how loops work because it helps you to appreciate what they're doing. Okay. But don't worry, I had no idea what recursion was until...
Unless you're in like a Google interview and they ask you.
Yes, yeah. But we don't do that nonsense here. I told you guys the most important thing for us is to get the work done. I don't care if you understand the most efficient algorithm for sorting arrays of Latin fish names. Like I just, yeah. I just want to know if you can get the work done. So the recursion piece is something that you generally don't run into, and you don't want to use it anyway for very practical reasons, which is that if you want, okay, if recursion is hard to do, it's difficult for people to understand. and you get it. You absolutely understand what recursion. Let me back this up a second. We're going to use a different analogy. You guys ever worked with like a filing system with a group of people before?
What system?
A filing system.
Okay.
Too young for that. You ever?
We'll
you're
imagine.
like okay. No, I have not
I've
done
seen
that.
one.
Yeah, I've seen one. What do you
No
mean?
one
Is
is.
that around with those fax machines or? Yeah. So, if you've ever worked on a group project with somebody before, and you had to keep some level of organization, and you thought you had it solved, right? Let's imagine that you think you've got it solved. You know exactly how you should be organizing these things. You think everything should be alphabetical, right? So you alphabetize everything, and then they come in and their expectation. So you've been alphabetizing. They've been using the Dewey Decimal System. All right. So you've been alphabetizing. They're like, no, this Dewey Decimal System makes so much more sense. Like I know exactly where to go to get the right content, and it like categorizes things. And like this is so much better if I'm searching for stuff. And you've got your alphabet system, and they've got the Dewey Decimal System. All right. Now the alphabet system, it works really well, so long as you understand that the alphabet system is there. Dewey Decimal System also works. It may be a little better, like in terms of finding the category and getting to the right place, right? But if you're doing the alphabet system and they're doing the Dewey Decimal System, when you go look at the Dewey Decimal System, you're like, what the jack is this? I have no idea what's happening, right? This is bewildering. I don't even know where to start. Like, I'm just going to throw my hands up. You got to come help me get through this to get it categorized in the way that you want it to. And I really don't want to mess up all your stuff, right? On the other hand, they come to your stuff, and it's an alphabet system, and they're like, yeah, oh, I get it. That's easy. I've known the ABC since my whole life, right?
Okay.
So I can help you to get your stuff organized.
I see where you're going with this.
Yeah. Now I bring in a third party. So that's one issue. We're going to come back to that in a second. We bring in a third person who doesn't know anything about your organization system, but they're going to join your team, right? Where can they start working the fastest?
The alphabetized.
The alphabetized system. But the Dewey Decimal System is better. What? Who cares? You can't do anything with it. You can't build code on that. And that's where I'm going with this, right? When you're building code, when you're writing code, you should not only be thinking about how do I make something that is technically better. You want to do that, but you want to do that in a way that is obviously understandable. Okay? So you get to the Dewey Decimal System awesomeness in alphabetization. So one way to do that, like a simple way to do that, is let's have a substructure where I have categories alphabetized, and then within each category, I have the things alphabetized. That's way better than understanding whatever the hell the Dewey Decimal System is. Mm-hmm. And you guys think like, oh yeah, well of course, obviously you would do that, but people don't do that. Like this. So as a great example that's very recent, and I can show you guys this, the file that we were sent. You've heard us complaining about this R deployment stuff that we have to do. We're trying to get these audiences, and this guy wrote it in a language called R, and we're trying to deploy his stuff. One of the things that he did that is really frustrating. Let's see if I can grab it real quick.
The Dewey Decimal System.
He did the Dewey Decimal System.
Essentially, maybe he sent that Slack. Yep, this guy. Okay. All right. So
Oh, dear God.
these crazy shit letters represent something. And he explains them and writes out what each one of these explanations are I can tell you that what they all end up being is something like fall 2019 applicants, spring 2020 registered. Okay?
What is this hash he's doing? Like, why is he?
Okay.
What
And
is
I know
coding?
that because that's what we asked him for. But he's done this crazy, and so look, I'm making fun of him. But what he was trying to do was a nice thing. What he was trying to do is say, look, to be able to say current umbrella term or applied is not relevant, or whether they're enrolled, or if they're dual credit, or the next umbrella term, or applied is not irrelevant, or not enrolled, or dual enrolled, and I take all the possible combinations of those things. It is a lot easier for me to write CZEHNZXH as the audience name. But the problem with that is nobody else can read it or has any idea what's going on with it. And the reality is that the combinations that we actually care about that you produce aren't that complicated. They all end up being current umbrella term enrolled, current umbrella term dual credit. That's it. We don't need all this extra stuff, right?
Mm-hmm.
And so that's what happens, and you're gonna do this. I guarantee it, especially early on. You're gonna be like, oh man, I know how to solve this thing, and it's gonna be awesome, and it's gonna make everyone's life easier. And it's just not true. It's gonna make your life easier because you understand it, and nobody else is gonna be able to come in and help you out. And that's a problem. We refer to this frequently as over-engineering. And it's a problem, and there's a couple reasons why it's a problem. The first problem, and this is why we have to have conventions, and we have to do things the same way, even if you don't necessarily think it's the right way to do it, is that when people on your team go and they have to make a change to your code, which is going to happen, because you're going to be out of town, you're working on some other more critical path project, you leave the job and go on to do something else. When somebody else has to work on your code and it doesn't conform to the conventions or standards that they're expecting, they're not going to know what to do with it. So they're going to throw their hands up and they're going to come to you and they're going to take you off of that critical path or out of your vacation. Or they're going to let you be on vacation and we're not going to be able to move forward with the work until you get back. And that is not a thing that we can do, especially not in an organization like this.
Mm-hmm.
The second reason why you want to do things simply in terms of writing your code is that when you bring on new people, so you guys, right, when we bring you on, you're going to look at our code and you're still going to be like, what is this? What are you guys doing? This is nuts. There's so much simpler way, or I think we should be doing it this other way, or whatever. Eventually, you'll come to see like why we didn't. Sometimes it is just like on this team, it's never because people were lazy. I can tell you that. It's because we didn't have time. Like we probably even saw what the issue was with the code that we were writing, but we're like, it works. We got to move on. We're just going to shove it in. Mm-hmm. Generally speaking, though, we try to write code that is reasonable that other people can come into, and that's because if you guys are going to come on and you're going to start working on our code, it needs to be set up in a state where you guys can be like, oh yeah, I get what they were doing there. I can read this code. I know what's happening. If you do some nonsense like this, nobody can ever come and work on the code. Okay?
Yeah.
So we have to be obvious, right? That's why you don't use recursion. That's why we don't care about algorithms. Because the work that needs to be done at a reasonable price point and quickly enough, it has to be readable, it has to be understandable first. Okay? It has to work first, it has to be readable and understandable second. Okay? And then it has to do really cool things that are highly performant third. Okay? And I think a lot of the times what happens to us as computer scientists is we want to flip it.
Yeah.
We want to be like
First efficient,
mm-hmm. Then the code is good, then it works. Because those are the things that we're focusing on. But it's not practical. You can't make a career out of that. You can't make real product when you're looking at things that way. Okay? It's got to go the other way. All right. Massive aside, but I think a good one. Back to loops. All right. So simple. Start at 0, stop at 10, start at 1, stop at 20, whatever, right? Just for going through. And more or less, that's just a list. It's the same as an array. We could create an array that had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We just don't want to write all the numbers. Okay. Most of the time, we're going to end up with a list of things. Recursion does basically the same thing as a for loop. It's much more consistent, actually, with the way while loops, if you run across those, are written. Don't ever write a while loop here. I'll get mad. But it's basically the same concept, which is there's a while I is less than 10, so it's essentially this. Keep doing this loop, and then once we pass that condition, it'll kick out.
What's wrong with a while loop?
They're not readable, dude. It doesn't matter anyway because here. Let me show you. When most of the times we're using a list, you have an array of things. Okay, so let's say that I have an array of people. All right. I can loop over this in a couple of different ways. I could do what I think is the simple way. Now, even if you weren't a computer programmer, I'm pretty sure you could tell me what that's going to do. For each of the people, log the person. You might not know what console log is, but if it said print instead, you'd be like, oh, it's going to print the person. Or if it said say, it's going to say the person, right? Okay? The equivalent in a while loop would be while people dot length less than 0 print. There's some way to get the access. This is how infrequently I write while. There's some way to get the index. While, so print people I. Now you tell me which one of those is more readable.
Yeah, but I feel like a while loop, it serves different purposes in terms of like you're testing against a condition. So if your condition is a number condition,
Mm-hmm.
I mean, of course, just go ahead and use a count control.
Yeah.
But like if you're testing like some nullity, you know what I'm saying? Something like
Yeah.
that.
Yeah. If you have some theoretical problem that you're trying to solve.
As a player, you know what I'm saying? You go down a linked list. You're
Yeah.
gonna say
It's just
while
that's part of
the-
my point, right? Like, so again, 85-90% of the time you're gonna have a set list that you're looping over. Okay.
Yeah.
So yeah, I get it. There are certain problems where you need recursion, where you need a while loop, where you would do a for loop where you're doing from 0 to 9 or whatever the case may be.
Mhm.
They're just very rare. And so in those cases, when they happen, so that's the other thing to think about, right? So, okay, so these things are very rare. A while loop might make some more sense, okay? So like a while loop maybe makes more sense than a general for loop. But I'm used to 85-90% of the time seeing something that's a list and a for each, okay? So if I'm going to write something that goes from 0 to some number,
Definitely go count control.
yeah, that's right.
And
And it's just
for each
because
is way better too.
yeah,
For
that's
each
right.
is good.
Just because that's what you're more used to that syntax and understanding what it is. Okay. So I get like, yeah, technically it probably makes a little bit more sense. And if you understand while loops very well, or you understand recursion very well, it might make more sense to you to use one of those. And that's cool. But it probably doesn't make sense to a brand new dev that you're bringing on.
Don't do it here.
So don't do it either. Okay. All right. Yeah, and depending on the work that you're doing, there are differences. Like there is, if we were doing massive game animation analytics, we might have to flip flop. We might have to say it has to be super performant because otherwise it doesn't work. Now the reality is the thing that's driving that is still it works, right? But its works definition becomes much more dependent on the performance piece. Okay, but they run into performance issues a lot more frequently in that world. Or if you're doing big data analytics stuff, you run into efficiency stuff much more frequently. Okay, and so there may be some reasons why you sacrifice readability, legibility, and readability, legibility, especially for the performance piece. But here we're not going to do that. You'll never, rarely, once or twice a year, you'll run into a performance issue that will hit. Generally, we find it in production because we scale up to something that's large enough, and it's like, oh, I see it's starting to slow down. We have graphs and stuff that tell us all that. When we started to see some spike, there's a couple of ways that we deal with it. Generally, we first say, okay, for the moment, just scale up. just pay more money for hardware. It'll
Yeah.
take care of it. And then if that's too expensive, we'll go spend the time and get the performance to come back down. Okay? So like don't worry about the performance because we can just pay for the week that it's
Yeah.
higher to for more hardware, and then we can scale it back down and we can take care of it during that time period.
Okay.
It's important to understand like what your restrictions are. Okay. All right. So there's a for each function you can do, particularly in TypeScript stuff. When we get there, you can do for person in people and loop over things that way. So those are some basic, just like you have a list, you're going to loop over them. There's for each. There's for. There's also a map. Anybody know the difference between a map and a for each?
So at the for each, will just give you each element
Mhm.
in that name callback function, but then the map will give you each element, but you're able to return something that's different or the same. You know, you're able to change each one, like mutate each one, I guess.
Yeah. So So we're just going to look at the difference between these two things. And I actually don't know what's going to happen. It could be for each does something crazy that I don't know about. But Logan's generally right in programming. The difference between them is that maps are used for manipulation. So maps are used to say, I want to take each item that's in my list and I want to change it. I want to transform it into something else. And then I want to return it in the same place in the array, so that I end up with an array that each item has been transformed in the same way. For each is intended to be more like a void function, where I want to loop over them and maybe do something to them, but in a temporary way. I don't want to end up with a list of them transformed in any way. We're going to go through and we'll see what I mean by that. So if we just do return person plus something. And then we do the same thing down here. So we can see in the first case, so for each function, that's the first thing I'm logging out. Here, I'll put just so you guys can actually see I'm not like messing with you, which I don't do usually. But. All right. Occasionally for fun. All right. So there's the for each function. What I get back from that is undefined. But what I get back from the map function is each name concatenated with something. You see that? So
Can you go back to the code?
Wait, why does it say undefined?
because it doesn't actually get anything back. So the whole thing is that for maps, what you're expecting to be returned is an array of your list where each item has been transformed in the same way, where it has been transformed by whatever you did between the two curly braces. For a for each, you generally don't set it equal to anything. You just do something like that. So it's a void function where you're just like so you don't return anything in a for each. You would do, but you can see the difference is I never end up with an array in the for each condition. I do with the map. If I wanted to accomplish the same thing that I'm doing in the map function with the for each, you have to first define a variable that's an array up here, and then you could do something like which pushes, so you're creating a new array from the transformed data.
I see it. Okay. Nice.
So, and then you get something very similar. Okay.
So map just like straight gives you an array versus
It
for
return-
each would return it.
Yes, that's right. A map function will return an array
Okay.
of each item transformed by its function. The for each does
It's
not.
just a list.
It's just a list. And you're just looping over the list, and you can do things in it, but you can't. But it doesn't return anything. So generally speaking, if you want to end up with an array where each item has been transformed by your function, you use a map. If you're just trying to loop over things and do something, like maybe you just want to, like maybe you don't care about the array, getting back an array that's been transformed. Maybe you do just want to do something like log out each of the people one at a time. Then you don't care. I don't need an array back, so I'm just gonna loop. That makes sense. Now it is important, you have to put this return key here, especially when you get to the TypeScript stuff, or you're not gonna get anything back. Okay. You'll end up with an empty list. Okay. We're gonna ask something else, guy. You're good. All right. So that's for each, that's map, and then we're gonna do one more today, which is filter. You have any idea what the filter function does on an array?
Filter with some condition,
Yep.
and then depending on that condition against what you have in your array, how that tests against it, it'll either return the items that fall under or not.
Yep.
That meet the condition.
All right. So
Add the C to the end of function at the bottom on line 21.
what's that?
Fun.
Let me just see. Okay.
And the map on line 4, I think has to have
Yep. Okay. So if I do that, what do you think I'm going to get back from my filter function?
This one includes a.
So you'll just get Sam and Jane.
Okay. So can you walk us through that, Logan?
So when you on line 15, when you run people.filter and you give the anonymous function, it gives you like each item
Mhm.
as a person,
Mhm.
and then you say return person not includes a. So you say like if the includes method, it tells you if the string has this other substring inside of it. And so it goes through each one and says, okay, does this person have an A in it? If it does, then it returns true, and the filter function says, oh, okay, you want to keep this element in the new list. And if it doesn't have an A in it, then the filter function says, oh, you return false, you don't want this one in the list. So Sam and Jane will be in the new list, but Wendy won't.
So this is very useful for doing like searches of arrays. You can do all kinds of things with it, but essentially what it does is you're returning true or false for each item in the array. If you return true, then it keeps it in the array. If you return false, then it removes it from the array. Okay. So yeah, it'll give us back what Logan said, and we're just going to look at that a little bit more closely. So if I change this to be W, then we're only going to get back true for Wendy. So now we should just have Wendy in the array.
Mhm.
And if I change it to just be return true, what's going to happen?
You'll keep everything.
Oh,
Yeah,
it'll always be true.
you keep everything because it's always true. And so if I change it to be false, what are we going to end up with? We'll end up with an empty array. Yeah. You guys see that? So all I'm doing in this evaluation with this return is deciding on something that's going to make it true or false. And if it's true, we keep it in the array. And if it's false, we drop it from the array. Okay. So this is really useful for like a search function. Like what I had set up there before is very similar to I mean, what we have is more complex, but essentially when you type into the search bar, is basically what we do. We search and see, are there any people that have a first name or a last name or a phone number that includes what they typed in the search bar, and just give me back the list where they did. Okay. Right. Make sense? Right. So there are, now that you understand these basics, there are lots of, your best thing to then go look at is a library called Underscore, which does all kinds of things with collections that are more similar. They have more similar nomenclature and syntax to Rails, which is what we're going to get into next week. But you can do some nice things like you can, if you have an array of objects, you can say underscore where your array of objects. The author is Shakespeare in the year 1611. And it'll do a filter. So here, I'll show you the equivalent filter. Let's do it down here. Authors equals, what are the options? Author, or I guess it's books probably. What's some other authors and years?
J.K. Rowling.
Rowling.
Yeah.
2019, I guess.
Hughes.
Let's just do something like that. All right, so what we have is a list of books, right? And we're gonna loop over these books, but we want to only return the books where the author is Shakespeare and the year is 1611. So we're gonna do that using our filter function. So how would I do that using a filter function?
Author. Oh wait.
So there's a filter.
Book dot.
Yep. So we just want to return a true or false value.
Book dot author.
Uh-huh.
Equal Shakespeare. And year book here. Book dot year. Equals 1611.
All right, so you guys see what we're doing here? We're looping over each of the books. For each book, we're looking at its author property and its year property. And if its author property is Shakespeare and its year property is 1611, we're going to return true, which is to say we're going to keep it in the array. If it's not, then we're not.
Mm-hmm.
Okay. So if we then print out search results, what are we going to end up with?
One book.
One book. Which book?
An array of size 1
Mm-hmm.
with the author Shakespeare in the year 1611.
There you go. So there's search results. It's an array, size 1. The author of Shakespeare, year of 1611. Okay. So this is a little verbose to have to like write all of that. So what the underscore stuff does, we can't use it because I don't have it installed, but you could do, where, and then you pass in your array, so books, and then you just pass in a hash of what you care about. Okay, that's the same code. So it's just a little shorter. It's a little more readable. It's just saying where this array, and then you choose your properties. So another one that they have is like find where. And so then you could do something like, in our case, when we do database stuff, a lot of times it's an ID. So you can like find the books with an ID. Okay. And just return one result. So there's some nice things there. So it's worth looking into as you get more familiar with this. We'll use it as we get into the more difficult projects. But that is going to be it for today. I would actually like to go further, but I just don't have time for it today. But that's loops. So on Monday we'll do functions. And that's going to get you, I mean, you guys already have the 3 fundamental pieces of programming. On Monday we'll get into functions, which will make things a little bit more readable. It's going to make all of this stuff a little bit more encapsulated and more readable. And then on Tuesday we will switch to Rails. So then we'll do variables, if else, loops and functions in Rails. We'll probably get through them a little bit more quickly because it's just a syntactical change. It'll be a little bit of startup cost, and then we'll get you guys set up. Like you'll actually create your first Rails project. We'll make sure that you have that on your computer, all that. But then we'll move pretty quickly through those pieces. And we'll talk a little bit about Active Record and how you interact with the database using Rails, which would be kind of cool. We'll look at the console, that type of stuff. Once we get through that, the last thing that we'll do in Rails is look at classes. And we'll actually start looking at those immediately. We'll talk a little bit about instance variables and static variables and why they're different and what the purpose of those are. We'll talk a little bit about inheritance and object-oriented design and why you would do that. And then we will get started on much more practical things of like, okay, now let's build a to-do list and we'll build it all together. Like I know you guys have started working on the to-do list and you may have finished the to-do list by the time we actually get there, but we're going to do it again anyway because there's certain things that are like, you're going to be like, oh, I see. I could have made that much simpler. I now understand like what's really going on there. We're going to get a little bit more in depth into what's happening. So try very much to get the to-do list going. The to-do list will be due not Monday, but the Monday after that. So we'll do a demo on it. You won't actually at that point still have all of the pieces that you need to make it a reality. So you're gonna have to do the research and figure that stuff out. But we'll start to get into all the pieces that you need, and you certainly will have all of them as we move through that 3rd week. Okay, but we're gonna do a demo on the Monday. So not this coming Monday, but the Monday after that of where your to-do list is. I'm not, I'm not so, like if it doesn't work or there's problems or whatever, it's not so much what I'm interested in. I want to see progression. So we're going to start there. It'll give me an idea of where you are. The week after that, we'll probably still do another demo of the to-do list. We'll come back to it. We'll make sure that everybody got that done. Then we'll go onto the bingo leaderboard and we'll go on to Syllabi. So the same thing, like you guys, if you get beyond it, like I know Logan's already hit the bingo leaderboard and he's through that and Syllabi stuff. It's okay. He has a lot more he has to prove. So it's good. It's good, but the fundamentals are really important. So we're all going to come back and we're going to do it all the way through.
Okay. Sounds great.
Okay. Yeah.
Cool.
Great.